Morning, everyone. Welcome to the third in a series of Reliance webinars, and today's topic is programmable pneumatic replacements. My name is Jerry Graham. I'm the manager of Reliance Operation. I've been working for Reliance for over 40 years, selling automation for over 15 years. I've worked with most of Ireland's automation integration providers on many projects, from concept stage right through to FAT. I've also advised on many automation projects with end users, as well as as consulting and supplying goods for the projects. What we'll be covering today, right, an introduction to Reliance. Then we'll be going on to talk about electric versus pneumatic actuation, main differences, etc. We'll be talking about the two main offerings we have in this area, which are from IAI, which is Intelligent Actuators, and from Smack, SMAC, Moving Coil Actuators. We'll go into those in detail. We'll talk about the resources that are available, and we'll have questions and answers. Any questions that you have during this, just please look down there, or it's either the top or the bottom, but you'll find a chat box. Type in your questions as we're going along, and we have two people here, two panelists here with us that will answer them. One is Bernard Lawton from Smack, and the other is our own David Webb, our own applications engineer. So as you ask the questions, they should be able to answer them as we go along. Right, who are Reliance? Well, Reliance are a fourth generation Irish owned family business, started in Cork in the mid 1920s. The top photograph there shows a photograph taken around about 1928 in Cork. I think that place is where the bus depot in Cork is now, taken, as I said, around 1928. And the bottom photograph, well, that's the modern facility down in Little Island in Cork. We're Ireland's largest technical distributor. We operate predominantly in certain Irish markets like food production, pharmaceutical, biomedical, the medical device market, manufacturing, and transport as well. And we're ISO 9001 accredited. We have three branches in Ireland, one in obviously the Cork one, which is our head office. We have a Dublin branch and we have a Limerick branch. We have 45 full-time staff, 8 external sales engineers, and 40,000 square foot of warehousing. But the most important thing to emphasize here is we are a distributor, not an integrator. We have formed partnerships with approximately 20 integrators from all over the country, which allows us to deliver complete solutions, but we will never integrate ourselves. Right, programmable electric actuators. Well, they've been available for decades. We all know this. And we all know that they're out there. But the perception is that they're very expensive, and they always will be. However, their effective price has been steadily falling. And they're certainly more affordable now than they ever have been. They come in many different shapes and sizes. The range has been growing fast. They're now available at up to 3-meter strokes, both rod and rodless designs, higher speed than pneumatics, and the sheer range is just astounding. The smallest available would fit entirely on your business card, while the largest can handle payloads of up to 160 kg. They're being adopted into industry for 3 main reasons. Number 1 is the cost of providing compressed air. Number 2 is probably for controllability of the unit itself. And number 3 is because these pneumatic replacements are almost always maintenance free. The two offerings from Reliance in this area come from IAI and Smack. They share a lot of things in common, but they are very different types of technology, and we'll go through both in some detail. The things they share in common is their smooth operation, their smart programming. They're both quiet, fast, controllable, and very safe. IAI are made in Japan only. They've been in business for over 40 years and they've never made pneumatics. They are the major supplier of programmable pneumatic replacements in Japan and one of the leading in the United States too. IAI have never made pneumatics. Smack, moving coil actuators, they're in business for 30 years. They're made in the US only and are one of the leading providers of moving coil actuators in the world, and they've never made pneumatics either. Both have unique features. But before we go into that, let's take a look at the real cost of providing compressed air. I don't think anyone listening to this will be in any doubt that running large rotary screw compressors is an expensive business. They are often the largest single consumer of electrical power in industrial environments. As you can see from above, there's huge inbuilt inefficiencies involved in the production of pneumatic air supply. When you compress air, it heats up. It also secretes water. These are unavoidable. These two processes alone, the compressing and the drying and the cooling of the air, these processes alone will account for half the energy consumption. Of course, it must then be filtered and transported through the air cylinder for use. These compressors are mostly large rotary screw compressors. And this is what they generally look like. Let's take a look at how expensive they are to operate these units. Here's a recent example from an energy survey done by Reliance. It shows how expensive this machine is to operate. This one was fitted with a 250 kilowatt motor and was one of 3 units, all the same size, but the plant could run on 2. Let's assume for the sake of simplicity that these units are 95% efficient, run 16 hours a day, 5.5 days a week, 50 weeks per year. Let's also assume that they're always running under full load. Now I know this is a little unrealistic, but we're doing this for simplicity of calculation. We're also assuming that the electrical costs are 14 cents per kilowatt hour. How much do you reckon it would cost to run this in electrical power alone? Forgetting about maintenance or any other costs involved. And the answer is just over 162,000 euro. That can be surprising, but for most facility managers who are aware of this, it won't be any surprise. And that's assuming, by the way, that's just producing the compressed air. That's assuming no other inefficiencies. If you have a small leak in a pneumatic system, if you can hear that small leak, then this leak alone will cost you 600 euro per year in electrical costs. A pinprick sized hole, which you will not be able to hear, could cost you nearly 500. Initial cost, of course, is higher for these pneumatic replacements. As a general rule, electric actuators are probably at least twice the price of their pneumatic counterparts, maybe even more, depending on many factors. However, their initial cost of ownership can be outweighed by their cost of ownership throughout their lifetime. The electric cylinder is far more efficient. It produces its power at the point it's being used, and more importantly, only when it's being used. They can be spec'd with sub-micron positional accuracy, although 20, 10, and 5 microns are more standard. They can also be spec'd with higher speeds than pneumatic cylinders. Size for size though, generally speaking, the electric cylinders can't match the pneumatic counterparts for peak power, although most applications probably don't use the full power of the pneumatic cylinder. Importantly, it must be also stressed that the accelerations and decelerations can be programmed separately to allow more gentle movements, making the actuator easier on other processes and mechanical components. On the left here, you see a range, that are the kind of a sample of the total range that's available from IAI. And so let's begin by talking about the IAI range. On the right, you'll see a cutaway view of a typical rod cylinder from IAI. At the back here, you see this where the electric motor and encoder are. Almost all IAI units are ball screw driven. There's sort of a central ball screw here with a coupling connecting the motor to the ball screw. And the rod here is connected then to the carriage on the ball screw. We're just going to show you a video here that was taken at IREX this year. IAI set up in IREX a conveyor system. This conveyor system does not contain any pneumatics whatsoever. It is all electric. Okay, and we'll just go through the applications that are on this. Each one of these yellow pallets being moved around weighs 7.5 kgs. And in case, oops, sorry, we go back here again. Sometimes these controls can be tricky. There you go. In case your Japanese is as rusty as mine, the first application here is a slider unit. On the left here, it's shown if this was done by pneumatics, you'd have hard acceleration, hard deceleration, and you'd have a cycle time of 2.4 seconds. Because this high speed it reaches in the center of its stroke is not as high as can be done with the electrical. Here we have the electrical, smooth acceleration, smooth deceleration, making the components on the conveyor under less stress. But it can be done, more importantly, it can be done in a faster time. Here's the slider unit here. You'll see this in the video just as we run it here. So there's the slider unit. There's the carriage. There's the pusher. Pushes along. The second one is a little gate. Opening the gate and closing the gate. Here it is. Close. And there it just opens. Just pause there for a second. Here's the IAI LE cylinder unit, reverse motor, the rod connected here. So very, very simple gate application to allow the pallets onto both sides. This is the third application. It's a lift, and there's four. They're kind of hard to see, but there's 4 LE cylinders here. This one here in this corner is the easiest to see. So again, it's a reverse motor rod type. So there's 1, 2, 3, 4 units, and the total they're lifting here is about 40 kg, but they're doing it in unison. You can see the slider here again, our first application. There you get a better view of the lift units. Now, the next application on this conveyor system that I set up is a little bit more complex. And again, sorry about this. There we go. The next application is a little bit more complex. You've got 4 pallets that have been stacked. And what this needs to do is move the bottom stacked. Here we go. So if I pause this here a second. So these 2 here, these 2 units clamp the tree and then lift it. The lifting is done here. These ones down here are not LE cylinders. They're larger brothers, which we'll tell you about in a little while. They're Robo cylinders. These lift up the 3 pallets, and the slider then just pushes the bottom one away, so to destack them. See it there again. Drops, up, clamps, and repeats the process. And here you see the pallets being actually stacked after the first process has pushed them down. I was trying to emphasize there that the I/O system for the control of the IAI range is completely compatible with pneumatics control systems. The PLC controlling that whole conveyor system there would not know whether it's pneumatics or electric cylinders it was controlling. They do it. They're exactly the same. So the IAI series can support the 2-position 2 signal as well as the 3-position 2 signal modes. And most of the units also will support the 2-position 1 signal mode too. effectively this means that replacing a pneumatic cylinder with an IAI unit can be completely invisible to the PLC. Before I leave this slide, I should give a rough comparison because people are always interested in what price these things are. So let's take a rod cylinder, 250 mil stroke, replacing a 32 bore pneumatic cylinder. Okay, I'm not 100% sure how much this will cost with pneumatics, but I'm guessing around 200, 220 euro. For the equivalent unit from an LE cylinder range, the cost would be 492 euro for the batteryless absolute encoder. Excuse me. Remember, this controller is built in. So that's just a price comparison. Now here we see a slide showing the main characteristics of the LE cylinder. Like I said, they're fast and easy to program. The reason they're fast and easy to program is there's only 5 parameters to set. They can be programmed with either a teaching pendant or a PC program. There's only 5 parameters to set usually. Those 5 parameters are the home position, the away position. It'll come from the factory with the home position at 0 and the away position at its full stroke length. But you can change those. You can change the acceleration, deceleration, and velocity of each movement. The LE cylinders have a built-in controller. The controller is inside in the motor unit itself, and they're only hardwired discrete I/O control. That's the only way you can control these. They are literally meant to replace pneumatics. They're maintenance-free. They have a stable velocity even at slow speeds. But the one thing I should mention is their push mode. Most of the time, these units would be operating in position modes. So they move to a designated position as set in the program. If it can't reach that position through a blockage or something, it'll trigger an alarm. But it can also operate to that position in push mode. In push mode, it tries to reach the position. But if it's prevented from doing so, it will send a position end signal and move to the next operation. The user can set the percentage of the motor power the unit may use to overcome this obstacle. So this can be useful to find things. The push mode in the LE cylinder is only available in one direction. Now I mentioned that the LE cylinder is I/O only, so it comes with a cable, pigtails. So you can see here the assignments of those I/Os. So the backward and forward positions, the alarm, etc. But the main thing to note here is that you have 2 options available depending on the safety category you wish to meet. You can have one 24-volt line for both motor and power, or you can have these 2 separated, as in B1 and A2 here. It really depends on which safety category you want to use and how you want to implement these, but both options are available. I mentioned the bigger brothers of the LE cylinders are the Robo cylinders. Generally speaking, there's a wider range available. And they all have batteryless absolute encoders as standard. They're an optional extra on the LE cylinders, but they come as standard here. They all have high resolution optical encoders offering 20, 10, or 5 micron repeatability. They're all maintenance free. They also have a built-in controller option, but it's a very different type of built-in controller because it can't operate on I/O. It can only operate on, as you can see here, these field bus options. You can have external controllers, single type or multiple type. We'll go through that in a second. But it's also important to note that these are heavier duty. They can handle higher payloads, higher speeds, and they can work on 24 volt or 45 volt. I'll explain more about that in a minute, but you're always only supplying 24 volts to the controller. Right, now a little bit more about the Robo cylinder. They're obviously available in the rod type as well as a slider and a wide slider type here. You've got clean room options, you've got splash proof options, You've got grippers, there's a massive range of them available. The types of controllers you can get, you can have the solenoid I/O type to replace pneumatics as an external controller. You can have a pulse train control, or you can have all those field bus options I mentioned earlier. You can have multi-axis controllers, which we'll go through a little bit more in a minute. There's also the mini Robo cylinder. These are advanced miniaturized Robo cylinders with 24-volt servo technology, and they also come in ISO sizes. You might remember I mentioned that you can have an actuator, a small enough to fit on your business card. Well, there she be. This is the table type, and that's a typical business card that is completely fitting on that card. That's how small they can be. And here you actually see they also come in splash proof and clean room type. These are airport for vacuum. So if they are used in a clean room environment, you can literally vacuum away any possibility of contamination. This is one of their external controllers. It's an Orcon. It's a modular control system, and it can handle up to 16 different actuators. Okay, all the normal field bus options are available on this one, but just to show you what it's made of, go through here the sections. The first section here, well, that's the gateway unit, and you choose which gateway at the time of order. Okay, you can't change it afterwards. Number two here is a very handy unit which you only need if you're combining some of the heavier duty IAI units that use 200 volt with their normal 24 volt cousins. If all yours are 24 volt, you don't need that. That just allows you to incorporate the 200 volt and the 24 volt on the same field bus. Then you have the individual driver cards. When they have 2 ports here, you see as all these have, then they're outputting 24 volts. But you can also spec these cards with 1 port. In that case, they output 45 volts and you get higher payload and speed capabilities for each individual unit, but you're still only supplying 24 volts to the controller. That's a really important point there. Okay, you can mix the 2 cards with the 1 card on the 1 controller. You can have any control mixture you want. You know, so these controllers are relatively new to the market, and we've only sold a couple of them so far, but they are very popular because the amount of space, control space in your control panel they save is huge. If you have all dual cards, you can have up to 16 axes in the 1 unit that will literally fit in your hand. Just before we finish with the IAI, they do other non-pneumatic replacement type products. They do these interesting wrist units, which are like the J5 and 6 of a 6-axis robot. So you have the J6 and the J5 unit, which you could mount on anything you want, other actuators. I normally sell them with a 4-port for programmable controller. So this could give you 2 axes to support this last 2, control all 4 from the 1 control unit, which will give you full programmability. So you'll have interpolation between the 4. That can give you very inexpensive way to get into SCARA type operations. These are tabletop units here. 500 by 500 is the maximum size. Again, these are programmable. So anything that from the IAI range that's programmable, you do not need a PLC. You can program them completely and they can control other peripherals. IAI do actual SCARA robots themselves as well, and they do rotary indexing tables, and they do very large actuators. These rotary indexing tables, these can handle payloads of over 250 kgs, huge high resolutions. These are very specific units for large industry. They do geared units for smaller indexing tables as well. That's the IAI. Now we move on to the SMAC units. SMAC moving coil actuators. Well, they're very different to the IAI units. They have no ball screws, okay? And apart from the linear guides, their drive is contactless. So their only contact is the linear guides, okay? They have absolutely no drive friction whatsoever. They're capable of super accurate programming of position, velocity, acceleration, and deceleration, and much more, and more importantly, force. They can be very useful for a wide range of applications, which we'll get into. If you have a look there at the various different ones you can see in that photograph, underneath there is the tagline, the ability to perform tasks and verify its quality at the same time. We'll get into this more a bit later, but in almost all applications, a SMAC unit can tell when it's performed what it was programmed to do properly, or when something has gone wrong. And most of the time, it can tell what went wrong and report the condition back to the PLC in real time. That's what gives these units the ability to perform the tasks and verify their quality at the same time. Here we see a linear rod type actuator, and I just want to explain in principle how these things work. It's a rectangular unit. Let's get into what we're looking at here. Okay, very hard to explain this, but I'll do my best. Right, here we have the moving coils, right? That's the actual unit there that's going to be moving. It's a cutaway view because what the moving coil here is surrounded by a stationary permanent magnet. These are very powerful rare earth magnets. So by varying the direction, amplitude, and frequency of the current sent through the coil, which of course can be done very accurately by the controller, this causes the coil to move as its varying induced magnetic properties react to the stationary powerful magnetic lines of the permanent magnet. The coil assembly is supported by an oversized linear guide. This linear guide has its own lubrication reservoir. The flexible cable provides the current for the coil, and it's life tested for 2 billion, not million, 2 billion cycles. So this makes the whole unit very, very, very long lasting. And we'll actually get into a bit more about that, of course, in a little while. They're available with 3 different levels of encoder. 5 micron repeatability is standard. For more accurate positioning, there's a 1 micron and even a 1/10 of a micron encoder available. So that's the linear rod type. There's also the linear rotary actuator, and this is it here at the top right. Very similar to the rod type, except the rod has a powerful servo motor actually on it. So therefore this has linear and rotary into one unit. They also have the cylindrical type. Working on the same principle, here's the cylindrical type. So the magnets here are surrounding the coil, which is connected to the rod. And here we have an overview of the various popular products from SMAC. First one you can see here on the top left is a cylindrical type, which we showed you. And then we have the linear rectangular type I showed you earlier on as well, but there's also a slide unit available as well as the rod type. And then we have the linear rotary, which is here, as we described in the previous slide. This one here is the cylinder type with a built-in controller at the back. Then we have the splash-proof IP67, dust-proof and splash-proof types are available in the rod types. They also do grippers and XY stages. An interesting product from SMAC are the robotic finger products. They react just like they use them for testing. They react just like a human finger. They've used them for testing the likes of Apple screens and button testing and stuff like that, because they push a button the same way a human pushes a button. There's also various different controller types, which we'll go into in a slide or two. But the key technical advantages of the SMAC units, well, they have a much longer cycle life. As we said, their cycle life is measured in millions of cycles. When SMAC get involved and spec the unit properly, and they do the testing and they spec it for they're confident that it's properly being used, they will guarantee the units for 100 million cycles. The main reason, of course, that can do that kind of thing is the drive system is contactless. They're actually very, very fast, of course. 24 to 30 hertz are possible, and that's even growing. We'll get into that in a minute when we show you a video. But one of the other reasons they can do things so fast is their response time of the control system. It can be sub-micron second, sub-1,000th of a second. It can be the response time. Like all electric units, they're extremely efficient. And as I said already, they're fully programmable in force as well as velocity and position. They also have a soft land feature. This is very useful, and we'll show you this in more detail in some of the videos. But one of the main things here, I think says already, they're fully accountable. Live process data is sent back to the PLC, so you know what they're doing when they're doing it. And of course, they're all silent. Here you can see the normal type table comparing the CBL units, the cylindrical units, to their pneumatic counterparts. No need to go into all this. Most of this is just showing you a lot of what I've already told you. Just to emphasize the point, they're maintenance free, and the total cost of ownership of these things when compared to pneumatics can be much less than pneumatics. The newer products coming out from the Smack range, we mentioned the LAR and LAL, which are the linear rotary and the linear units. Well, replace the A with a B, and you've got the LBL and LBR. These are the latest iterations for these units from Smack. They are actually lower in cost than the ones they're replacing. They're available with strokes of 25 mil to 200 mil, and they are stackable. I'll tell you what stackable means in a minute. The next photograph here is the CTL series. The CTL are electric cylinders. Again, they're lower in price than the ones they are replacing. Give you an example. A CTL 50-10, which is a 10 mil stroke, 5 micron encoder. That would cost around €550. Controller will be additional to that, depending on what type of spec you wanted on the controller. You can have the IO type, you can have the field bus type, and they're all different prices. But it could be anything from 275 to €500, that kind of price range. So I said the first ones there were stackable. Here's a photograph of a stack, which means you can quite literally stack these beside each other. They can work as a team, controlled by a master controller, and it's a very cost-effective way for multi-access applications. It should be noted that Smack make their own they make their own encoders, and they actually sell optical encoders. Don't think this is a single sale type thing, but it's just a point to notice. Smack also make multi-access controllers. Obviously, for the LBR series, you've got a separate controller for the linear and the rotary. So they sell dual access controllers, but they also sell multi-access controllers. And they also sell controllers with AnyBus and Ethernet IP as standard. They also have very low cost controllers. More about that in a while. But they also have GUIs. GUIs, well, these are graphic user interfaces. These provide a simple, straightforward way to quickly configure motion parameters of a variety of Smack units. They're designed for specific applications. They enable you to get up and running almost immediately after receiving your equipment. The applications so far covered by these GUIs are thread checking, capping, gauging, ejection, leak testing, and I'm sure more will follow. They require little or no programming experience. They're menu-driven, Windows-based, easy to set up. They're pre-programmed with the application-specific features, and basically you've just got to set it up using your specific points. And there are built-in tutorials to help you do that. So, typical applications for these Smack units. Well, one of the main ones would be pick and place. Pick and place applications, they're ideal for these because they're super repeatable, fast, and they can rotate as well as lift and drop at the same time. They are often deployed at the end of a SCARA robot or a 6-axis robot in this role too. They're also ideal for assembly work, as they can detect surfaces as well as give feedback on the work being done. Rejecting and diverting is often needed in industry, and it's hard to find a simpler solution than the Smack units, and we have a great video to show you that in just coming up here. Okay, this is a video that was taken in a Coca-Cola plant. The Coca-Cola plant is in the UK, and this bottle line is running at 800 bottles per minute. Okay, these bottles need to be ejected one at a time without interfering. Oops, I'm going to do that again. Sorry about this. Without interfering with the bottle in front or behind. And here we see exactly what's happening from behind in slow motion. Here is the body of the actuator. There's the rod, there's the pad that pushes the bottle, and there's the controller above it. And here's what it's doing in slow motion. Okay, here's a sample of the programming that's involved. And there again in slow motion is exactly what it's doing. So how is it doing it? Well, it's controlling the motion profile of the unit. And as well as controlling the motion profile, it means it accelerates through the bottle as it pushes it out, controlling the movement. But it can also, what also helps it do this is its response time. And you might think that this is the fastest that rejecting and sorting that to do, but here this shows you. Smack actuators have been successfully applied in ejecting and diverting applications in units that are 2.5 times the speed, 2,000 parts per minute. So they're amazing. Other applications, because of their high repeatability, when they're used for filling, the fill amount is very precisely controlled. So there's no need to overfill to avoid underfilling, as is often the case when it's done pneumatically. They're also used for leak detection, and this is one of their unique capabilities. So when in leak testing, what these things can do is, because of their soft land feature, they can move, detect the edge of the bottle. When they reach the edge of the bottle, assuming of course it's a flexible bottle, they then know they've reached it and then push with a predefined force. And as they push into the bottle, they have encoder counts, and they count how many times the encoder, how many encoder counts before the defined force is no longer enough to push into the bottle. There's a massive difference between a bottle with a leak in it and a sealed bottle. You know, example, in one particular test we did, between 17 and 19 encoder counts was typical for a sealed unit, and over 60 for a leaking unit with a tiny pinhole sized leak in it. So these things, because they can work so fast, can detect a leak in line on a production line. Also, measuring, boring. Because of the feedback from these things, you can use them to measure and gauge. So you can use them at the end of a tool, and as you move along the profile of something, they're reporting back to the PLC exactly where the rod is, and this can be used to gauge and measure inspections. Also, they have smart screw driving capability, capping, and tread checking. These are all very similar because they use the linear rotary unit. I'm just going to show you a video on this. Remember, the video is on the smart screwdriver, but the capping and tread checking are very similar, and there are GUIs for all three of these. So here we have the smart screwdriver. Again, this sometimes happens. We're going to go through that again. Now, it's going to show you what it did there, the 5 stages of what it did in slow motion. Okay, let's go through it. Right. It fast approaches and then finds the surface with a soft land capability. In other words, this could be a mil higher or a mil lower. This will still detect it. So again, if I just go back a small bit here, it detects it. Then it moves counterclockwise. Sorry, this keeps happening to me and I'm not sure why, but it moves counterclockwise to make sure the unit is not cross-threaded. Then it rotates and a point to note here is it does all this in real time. If I go back to the start of the video, remember it's doing all those things in real time this fast. And because of its ability to report back in real time, if there was no hole underneath it, it would know. If there was no thread, it would know. And it could report that back to the PLC. If there was no screw, it would also know, and it would know the difference between all 3 of those conditions. So capping is very similar, as I said, and so is thread checking. Okay, what resources are available? Resources are available from the SMAC website here. You can see it, smac-mca.com. You can easily create your account and log in, and there you'll get information on training materials. You get information on the individual products. You'll get 2 and 3D drawings. You'll get applications and case studies. You'll get SMAC connectivity and setup information, manuals, etc. And you'll get a list of the GUIs that are available. The GUIs are not free, by the way. The software itself is free, but the GUIs are a chargeable product. But they're not very expensive. I think they're around €250. Certainly they'll more than pay for themselves in time saved. Now let's see what resources are available for IAI. The IAI website is iai-automation.com-en. That's their European. Again, you get product information, 2 and 3D drawings, software support, documents and forms, certificates, and the latest products. But there's another resource for all the CAD models. Almost all Japanese manufacturers register all their CAD models on a website called Web2CAD. This can be a very, very useful resource. As I said, not just IAI. All IAI products are on there, but almost every Japanese manufacturer put their products on Web2CAD. If you simply Google Web2CAD, you'll simply get it. It'll be the first solution there. Okay, thank you very much for your time, guys. I really do appreciate it. And hopefully the questions have been answered in the chat box, if any. And more importantly, all of you that have registered for this will get a link to the recording of it. You can send it on to whoever you want, or indeed have a look back and just check on some of the things. If you have any other questions, even later, you can send them on to us. And thank you for your time. I appreciate it. Thank you.